I think we will kick off. So can I first thank you all for coming along? And essentially, the idea of these talks is to really support the development of our newer pilots. So firstly, by sharing some of the knowledge and experience I've gained over the past 4 years, and these are really things that I personally found very helpful. And secondly, by creating an opportunity for Q&A session at the end with some of the more experienced pilots of the club. Ultimately, the aim for all of us is to become more confident, safer, and more efficient pilots. So I put out a survey of topics that I thought might be interesting and I could say something about. It was a Google Forms survey, and 23 people replied. One more since then, but the results haven't changed. So the number one thing that people wanted to see was weather forecasts, followed by instruments and then Skew-Ts. Planning, then thermals, wing control. Not a lot between any of those really. And then right at the bottom was flying at sea and flying abroad. I'll try and do a talk in every 2 or 3 weeks. That might be a bit more challenging as we get into the flying season and outdoor activities. What I've done is decided to do the UK forecasts and Skew-Ts together. So we have a single module, if you like, on just the UK weather. And then we'll do instruments next and then really go through that list. I thought I'd swap planning and thermals and probably do wing control first and then possibly thermals planning. We had quite a good feedback, quite a response. About 25% of the pilots have done less than 10 hours. If you look at about 25 hours, about 50% of the pilots had got less than 25 hours in total. And less than 100 hours was about 85% of pilots. So that's a sort of audience that I'm trying to capture really. And hopefully we'll get some more experienced pilots here on this call. I've asked all our coaches in the club if they could attend, even if it was only for the last 15 or 20 minutes, to assist us in the Q&A. So here's a brief overview of my experience. I've logged just over 200 hours in just under 4 years, so I'm still relatively inexperienced. I've got a lot to learn. The furthest I've flown is 115 kilometers in Beer last October. The biggest triangle I've done, which is flat triangle, is 109 kilometers. Flat triangle just means that one of the 3 sides is actually quite small, and that happened to be an out and return flight again at Beer, and that took just under 5 hours. The fastest I've flown was a flight last year from Malvern downwind, and it was only 66k, but it was over 30 kilometers an hour. The highest altitude I've flown to was just under about 15,000 feet, which is again in India last October. The highest takeoff was about 12,000 feet up on the Midi when I flew down the Vallée Blanche and the glaciers there. And I've tried to measure my progress as to the amount of time it's taken me to do these flights. So my first XC flight in Annecy was about 11 kilometers an hour for 25 or whatever it was, 30k. And I've increased that over the years. And I was particularly pleased with the one I did in India because it wasn't downwind, it was just flying. So flying efficiently to achieve 25 kilometers an hour was a real milestone for me. So the plan today is to talk about weather, and I'm going to narrow it down to UK weather. We'll talk about soundings and we'll look at some examples of weather, and then we'll finish up with a general Q&A on just the weather on the weather topics, and then a more general Q&A. I suspect this session is going to overrun, so we'll just have to see how much time we've got left and you want to use it in the Q&A. So effectively, when we talk about weather forecasting, we are talking about 3 layers. There's underlying weather models, of which there are quite a few, and the one that we're very familiar with in the UK is the European model, ECMWF. And then there's various thermal and soaring models. Now there's not many of those around, and then over the top of all of that is an interface. So ultimately, when we're looking at weather forecasting, the underlying models are the same really for all of them. So one of the things you've always got to bear in mind with weather forecasting, it is it's only a forecast, it's not fact, and all the models can be wrong. It doesn't matter how flashy the interface is, if they're all using the same underlying data, they're all going to be wrong. And the other thing that's worth saying is if you wait for the perfect day and the perfect forecast, you'll probably never leave the house. And the only way that you'll guarantee you're ever going to fly is if you're standing on the hill. So generally good practice when you're looking at weather forecasts to look at more than one overall interface, but also look at more than one underlying weather model and see how closely they align. So this is the go-to app for the weather in terms of wind. And when we start off flying and we're doing mainly soaring, then it's the place we all go to. But even more experienced pilots still use Windy. It's not just used in the UK, it's there globally as well. And it's the go-to place really for the wind. And it's there it's shown that the basic model is the ECMWF, and this is the basic forecast you get on Windy. There's free and premium versions. The premium version you get a lot more, so you get better forecasts, more up-to-date forecasts, and they go further into the future as well. And you get hourly forecasts instead of 3 hourly. And like many weather apps, they're continuing to improve over the years. Even in the time I've been flying, there's been continuous improvements in these apps, and Windy is one of them. So that's the basic first place that you can go to look at the wind forecast, the wind speed and the wind direction. So that's the basic view. This just gives you a little bit more detail on their underlying models. So on the left-hand side there, you've got the 3 main global models, the ECMWF, the GFS model, and ICON tends to be used in Europe. And there's more higher resolutions models on the right. There's an ICON EU for Europe. And the UK Met Office has a UKV one, which is a much more high resolution one. So generally, the best one that we tend to use is ECMWF, particularly in the UK. For longer range forecasts, the GFS model might be more accurate. ICON tends to be better in Europe, and UKV, it's got a higher resolution, but I really haven't done enough flying in the UK to know whether it's significantly better than the ECMWF model. And this is a bit more detail on the resolutions of the various models that we've got. This happens to be a dump out of XC Skies, which is a global weather forecast that I've used abroad. And at the bottom there are all the weather models that Windy uses. So you can see that UKV gets down to 2 kilometers, whereas the ECMWF is 9 kilometers resolution, and the GFS, the global model, there is 22. Interestingly, Meteo Blue have got a forecast in there as well. And that's one of the forecast models that are actually using a bit of AI nowadays as well. So one of the things that irritated me a lot when I first started using Windy is that the numeric values of speed, average speed and also wind gusts are only given at sea level in the table. And there is a slider bar on the right hand side here that you can use to set the altitude that you're going to take off at. And the actual colours on the screen change, but these numbers, if you look back there, it was 6 to 13. That's 6 to 13 at sea level. And then when you change numbers back, when you go change the altitude to 600 meters, the numbers don't change, but the colours do. So what you can do on the desktop, on the web, in order to see those numbers, is you can use something called a weather picker. So if you close a panel of the weather on the left-hand side with this cross and do a left mouse, you bring up the weather picker. And you can drag this weather picker around and it tells you what the speed is at altitude. At the moment it's set to 0 altitude, so it's still 6. But if you change it to 600 meters, you can see now that we've got a speed of 9 miles an hour at 600 meters. The other way of doing it, and you get it on the desktop here as well, is on a mobile phone, it's really hard to get the weather picker to work. So what I found is on a mobile phone, and this is an Android, if you just click on these three bars and select forecasted weather, when you then change the altitude, you actually get these arrows up with the wind at altitude on. So it's something you can then get access to on a phone, which is probably what you're going to be doing in the field. So 9 there compared to 6 on the ground. So the next thing I tend to do when I look at windy is look at the wind. If you just click on the wind as opposed to the basic, you get all the wind arrows. And if all of these are aligned, then that shows there's a reasonable confidence in the wind direction. And if they're scattered all over the place, then you can look in more detail at the models. And if we find the icon, the ECMWF and the UKV models align, that gives us a bit more confidence. The theory is that the UKV model is more accurate in the mountains, but I just don't have the experience of flying in the UK, particularly cross country, to know whether that's valid or not. But it's a very high resolution model available only for the UK, 2 kilometers. The other thing that's worth saying about wind direction, particularly for newer pilots who will be soaring, is that there's been a lot of work put into the site guides about the ideal wind to fly on that site. And the places like Fockery, it's always a very good idea wherever you're flying, even if you're flying in the mountains, but when you take off, is to look at the terrain around you and identify whether there's potentially any issues with wind direction change. It could be turbulence, but in a place like Fockery, you can see on the left-hand picture that if Fockery has actually got this ridge on the left-hand side and a ridge on the right-hand side. So in between the two is a valley system, which is shown a little bit better on the Google Maps picture on the right. So you may think that the wind is only a little bit off to the north, and therefore it will still be okay. But what happens particularly at Fockery is the wind gets channeled by the terrain topography, and it just rushes through here, so it comes off the hill a lot quicker than you might think, particularly down if you fly further down here. So it's always something to be very aware of, the effect the terrain will have on the wind direction, but also on the wind speed. The meteogram is something that I've started using the last couple of years. It's really effective, particularly in the UK in autumn and winter, and it effectively shows you the cloud base and fog very efficiently. I live by the Pandy Ridge, and I look at this quite a lot, and it seems to tally very well with what's happening on the ridge, which is like 500-600 meters high, just opposite my house. And the meteogram will certainly save you a drive over to Pandy to be sitting there, or not even up there, just looking at it in cloud. So the meteogram is a very good feature within the Windy app, particularly in autumn and winter. There's also the airgram, which shows the change in wind with altitude, which is again something that's very important that we know about, and also during the day as the day progresses. And the way that these things work is, I think a full bar is 10 knots and a small bar is 5 knots. And I treat them like these bars as feathers of an arrow. So if you look down on the right hand side, that's the wind bar, and just treat it like those bits indicating the wind speed is a feather of the arrow, and therefore this is showing the wind it's coming from the east. It's an easterly wind. And this information is also available in the Skew-T diagram. The other thing that's quite neat is you can set up alerts, and this is both on the web and the phone app. You click on the heart, you can just go alert for this spot, and you get a whole series of options. If you've got the premium version of Windy, you just get so many options, how much snow you want to have happen, how much rain you want to have happen, so you just switch them all off. But you can basically set the wind speed and the wind direction, and for what time of the day and for how long in advance you want to have this alert. And sure enough, when you do that, the alert comes through. So if you're very busy and you don't want to keep checking the weather every single day, it's quite a good, useful idea to set up alerts for your local sites, and it'll just email you when you've asked it to let you know that it might be flyable. The other great thing that we've got in the UK is RASP. And after the wind indicator, RASP is the next thing I always go to, particularly to look at wind speed at altitude. If you're a cross-country pilot, this is also effectively the first place you'll go to look at things like updraft velocity and whether it's a star-rated day. We tend to use a foot launcher's star rating because that's for paragliding pilots. Star rating normally is for sailplanes. One of the problems that we have with RASP is the interface is not very good. You've got a desktop and a mobile application, but when you start to zoom in and out, all the text just disappears. So the interface is pretty rubbish. But RASP is very good at predicting convergence. And so typically this is convergence with the sea breeze coming in, but quite often on cross-country flights, you can have convergence inland, 100, 150 kilometers inland. And if you're wised up enough and you've set your flight instruments up accordingly, you can start sometime during the latter parts of your flight flying these convergence lines. And RASP is very good at doing that. The other thing that I tend to look at is buoyancy shear. The jury's out really on whether that's useful to use in the UK or not. But I know some pilots that do, and I know some that don't. And the buoyancy shear indicator, you really want a value above about 5. And that says that the air is quite buoyant and it's not being sheared by wind. It just basically tells you what the quality is of the air that you're flying in, thermally in. So anything that's above 5 means the thermals are going to be quite easy to fly in. So that's a really good output from the RASP. Some of the things you do in RASP are limited to what's on the term point maps. So this is the British Gliding Association. So there's a British term point map here, and you can zoom in on these. It's not very good, but you can zoom in and find out what the local term point is to the place you're going to be flying. So this is Clodagh. CDK is Clodagh for flying at Pandy. And this is a RASP meteogram. And it's quite a complicated picture, and there's a very good video when you go to this website on RASP that explains it. But it's basically putting all the information from everything in RASP into a single picture. So it tells you the wind speed at low level and altitude. It tells you how it changes during the day. It tells you how much cloud cover there's going to be during the day by this top picture here. It tells you what the freezing height is and how much lower cloud base there's going to be, cumulus cloud build-up during the day. And these birds here are telling you the thermaling height. So that's pretty cool. My experience is that these thermaling heights tend to be quite pessimistic, and you can normally get a bit higher than that. So that's a meteogram. They're quite limited the places you can actually get them, unfortunately, on RASP. Something I used to use when I first started paragliding, but I've stopped using, is a blip spot maker. So once you know the BGA term point, it literally plots out a graph of things you might be interested in, like cloud base, the thermal strength, the thermal top. And then on the right hand side here, you can look at how the wind is going to change through the day. And you can also look at the wind speed during the day. One's a surface wind and one is the upper wind, which is the mid-boundary layer. The boundary layer is between the ground and the height that you're going to thermal to. So it's either the inversion height or it's cloud base. There's something called lazy RASP, which gives you a whole lot of pictures during the day, 12, 2 and 4 o'clock. And there's limited parameters you can look at, but it gives you a picture straight away across the whole of the UK. But I tend not to use that much these days. What I do use a lot is XCPara. And XCPara takes all the underlying RASP data and it just has this fantastic interface. And it's got a 50-50 button down here. And if you click RASP, you get only the RASP colours, the RASP colours, and no map underneath. If you just click Google, you get all the abnormal Google map without the RASP colours. So 50-50 shows you both. And you can quite easily, either on your phone or on the web, just click through the times of the day, and you can click through the days in the future. So if you click through all of these within seconds and click on, say, 2 o'clock, and you can immediately see if you're whether it's going to be a good cross-country day. So it's a much better interface for RASP. This was a very good flying day, by the way. 26th of March this year, there were 14 flights over 100k from Longmind. I'm just going to ask you a question on a poll. Can you actually have thermals on a 0-star rating RASP day? So you look at RASP and everything, the whole map is blue. So it's basically saying it's not a cross-country day. So can you just submit your responses? So the answer is yes, you can actually have thermals, even on a blue star day. And if you look at the definition of what the star rating is, it's based on the thermaling height. So if you've got a thermaling height of, say, 2,500 feet, or maybe only 3,000 feet, it's not going to give it such a high rating. It's expecting like 4,000 or 5,000 feet. If there's quite a lot of wind around, it will also change that rating. If there's no cumulus clouds being formed, it will also deduct 0.5 from the rating. And if the buoyancy shear ratio is too low, it also deducts some data. So you can, even on a blue star day on RASP, go out and be thermaling at our local sites. And I've been at Fockrugh at 9:30 in the morning on a blue day and been thermaling. And I've been at Hay Bluff in winter, again, 0 stars and still thermaling up. So all the star rating on RASP is trying to do is, instead of you having to look at 4 or 5 plots, like thermaling height, buoyancy shear ratio, the wind speed, etc., it just puts it into a numerical value. But you can look at all the individual plots and make up your own mind whether it's worth flying. Another app that's been developed significantly over the last couple of years and continues to be developed is Flybubble. It does give you a very good overview of your local area. You have to click this star at the top here to get the RASP star rating. It tells you what sites are flyable and not flyable, and it tells you by a color scheme here whether it's flying or not. So if you're very busy and you just want a quick overview, it's certainly something that it's worth looking at.
Quick question there, Chris.
Yeah.
Is the flyable taking account of the wind direction for the site?
I don't know the answer to that.
Okay. Then I'll take that away to find out.
I don't know. I would have. I don't know whether it's just, yeah. You would hope it would,
Yeah.
because up here is a windrose with the site on for Hay Bluff. So
my understanding is that it does. Yes.
yeah, there's
Sorry,
the optimum wind direction for
Yeah.
Hay Bluff, and therefore it's gone green. And these sites
Yeah.
are saying not flyable, so I suspect it's because of the wind direction.
Yeah. I have noticed that I don't know if you'll get to it, but Sky Sight's distance does not seem to account for whether or not a hand launch could actually take off on that site. So it's interesting that Flybubble, obviously more paragliding focused, is doing so.
Yeah, they put a lot of effort in, so maybe it's yeah, it's more accurate than some others. If you happen to be flying, say you were going to be flying at Talibont or somewhere like that, the UK Met Office has done a really good job at forecasting wind speed, wind directions, but also at altitude. Again, I haven't flown enough to know how accurate that is compared to, say, the windy altitude forecast. But if you're flying any of those sites, you can go into the Met Office website, and you click on one of those links, and it shows lots of other different sites underlying that in that area. So it's certainly worth looking at the mountain forecast if you're going to be flying anywhere near there. If you just want a general weather overview, the synoptic chart, the surface pressure charts are very good. And if you notice there are a lot of strong cyclones around on this chart, all the weather models are predicting that that's going to track a certain way. But if there's a big high pressure, say just below it, you can have a reasonable idea that if the wind speeds on the day are a lot lower than was forecast, that maybe this depression has tracked in a completely different direction. And I think that's occurred this week, because the forecasts later on this week were quite bad, for Thursday, and they've suddenly changed. And I think that's because these have tracked in a different direction. I first started using this weather and radar app. Again, these are the surface pressure charts available on the web, on the phone, as indeed the weather and radar is. And you can use this one worldwide as well. is I wanted to do a flight over in Chamonix, and I was just interested in light winds, but just good clear skies. And I basically went over Chamonix based on surface pressure chart practically, and the forecast here, weather and radar. And I've used this. I'm not going to be really talking about forecasting abroad, but I use this a lot now when I'm abroad, because the thing that stops you from flying a lot in Colombia and India is rain and cloud, and not lack of thermic activity. And I found this a very, very powerful tool to predict whether it's actually going to be flyable because of the low cloud and rain abroad. This app in itself is starting to use AI machine learning. And I think in the next couple of years, a lot more of our apps and interfaces will start to use machine learning to start with, and maybe even some of the more in-depth features of AI. This is a synoptic chart on a good flying day in the UK. Immediately after the cold front, you've got low pressure air converging and going up. So even though the high pressure is building, immediately post frontal, you get a very good air mass and very good convecting air going upwards for thermals. Ventrisky is another app which has been developed a lot in recent years, and I do believe it uses a bit of AI. You don't get much on the free version on your app on your phone. You've got to really go premium to get anything useful out of this. But on the web, you actually got a lot more facilities. But it does give you a reasonable idea of wind speed at altitude. So it's another possibility. It's not something I've used very much. Meteor Blue is something else that's had a lot of development in the last year or two, particularly with some AI stuff in there. It looks very, very detailed. It's got a very good interface. I don't know how accurate it is. I did a ChatGPT search on it. It doesn't seem to think it's very good from a thermal accuracy point of view compared to other apps like SkySight, which is one of the global go-to weather apps, basically, along with XC Skies. Interestingly, it does actually identify the rubbish interface that RASP has got, giving it only 2 stars. But it's certainly worth having a look and maybe a play at the web version for free. The other thing you can do is look at weather stations, and you can use this globally, basically. And this app will show you what weather forecasts are available in the area that you're in. And I tend to use it to calibrate the forecast I'm having on the morning that I decide to go flying. So here is a typical one for Blorange. But in order to calibrate it, whether it's worth flying or not, there's going to be 2 errors. When you compare the weather station with the weather forecast, there's going to be 2 errors in there. Possibly a weather error on the forecast, but there's possibly going to be an error in the position of that weather station. And that'll be dependent very much on the wind direction. And even if the wind is in the wrong direction for Blorange, I'll still use it as a means of calibrating how wrong the windy forecasts are in general in my area compared to how wrong it's got at Blorange. And there, what we really need to know before we do that is a calibration of that weather station for different wind directions. And I think that information will exist in our club, but I've never seen it written down. And basically, that for these wind directions, that weather station will be out by this amount. And if you know that, when you then compare the weather station with the forecast, you can have some idea of whether the forecast is wrong by 2 or 3 miles an hour, and then apply that delta to whatever site you're going to be flying that's using the windy app.
May I interject there, Chris?
Yeah.
It's Rich Harding.
Hi, Rich.
So, in my experience, but obviously we're going to have to recalibrate our knowledge of this, having had the sensor fixed. But prior to the sensor going AWOL during the snow, what Blorange Blorange weather station is very, very at Holfoy is very accurate, except in a southeasterly or east southeasterly, when Blorange obviously is actually flyable, particularly if it's thermic, where counterintuitively it tends to overread by 3 or 4 miles an hour, because what's happening is the air is getting pushed up over Blorange and then it's tumbling down quite fast onto the Holfoy, and therefore it overreads in an east-southeast or southeast. That's my main contribution there for that one.
Oh, that's fantastic. Thank you, Rick. So that's very useful. Thank you. What I'd like to do now is talk about soundings, which is probably one of the most important things that we need to be aware of when we go flying, whether it's soaring or even cross country. And there's loads of stuff available, but I found 2 videos really useful. One how to apply it, but one to how to understand it. So I could spend 3 or 4 minutes explaining it myself, but I think I will show you this video.
Okay, this is an introductory video that goes over the very basics of Skew-T Log-P diagrams used ubiquitously in meteorology. So this is a Skew-T Log-P diagram, also known as a thermodynamic diagram or a sounding diagram. There are 5 sets of lines in this diagram, and we are going to go over each one of them one by one. So the first 2 are in the name of the diagram. The T in Skew-T refers to temperature, which is our horizontal axis and spans the typical range of temperatures observed in the atmosphere from about -50 to 50 degrees Celsius. And then the P in Skew-T Log-P refers to pressure, which is our vertical axis, where up can literally be interpreted as being up in the atmosphere. This pressure axis ranges from typical sea level pressures of around 1,000 millibars to pressures typical of the upper troposphere or lower stratosphere of around 100 millibars. The log in Log-P refers to the fact that the pressure axis is scaled logarithmically, which can be seen by these 100 millibar intervals increasing in spacing as you go up the vertical axis, which we are thinking of as up in the atmosphere here. We can see that these logarithmic decreases of pressure correspond to linear increases in altitude in terms of distance, which we can see on the right vertical axis. The skew in Skew-T refers to the fact that the lines of constant temperature, or isotherms, are skewed 45 degrees clockwise, which is mostly done out of convenience so that we can plot a wider range of temperatures in a more compact space. But this skewing makes these charts a little counterintuitive for those who have not worked with them before. So, for example, if we imagined that we measured temperature going up in the atmosphere and it looked like a vertical line on this diagram, our first intuition might be that temperature is constant with height. But this is not the case. Instead, we can see that we are continuously crossing lines of constant temperature, and thus temperature is decreasing with height. It may be easier to see this if we momentarily unskew the temperature axis, showing a negative slope in our hypothetical measured temperature. So this is a temperature pressure space, and thus we have one set of lines representing temperature and one set representing pressure, but we have 3 more sets of lines to explain. The first of the remaining set of lines that we will explain is water vapor mixing ratio, or the ratio of the mass of water vapor in the air to the mass of everything else in the air, which includes nitrogen, oxygen, argon, increasingly CO2, etc. And this is in grams per kilogram. When mixing ratios are plotted in this temperature pressure space, they're telling us how much water vapor can be contained within a parcel of air of a given temperature and pressure. This is known as the saturation mixing ratio. So a parcel of air with a pressure of 700 millibars and a temperature of 15 Celsius would hypothetically be able to support as much as 15 grams of water vapor for every kilogram of dry air. Another way of saying this is that at 15 grams of water vapor per kilogram of dry air, this air parcel would become saturated, and any additional water vapor added to the parcel would condense and form clouds. We can see that at the coldest temperatures on the diagram, the atmosphere will have a capacity to contain only a very, very small amount of water vapor. And at the warmest temperatures on the diagram, the atmosphere can accommodate around 40 grams of water vapor per kilogram of dry air, or close to 4% of the atmosphere by mass. Now if, in addition to the temperature, we also measure the dew point temperature of this hypothetical parcel of air, we can plot that in this temperature pressure space as well. The dew point temperature is telling us the amount of water vapor actually in that parcel of air, in this case 10 grams per kilogram. This means that this parcel is subsaturated since it contains less water vapor than it would possibly be able to accommodate. It contains 10 grams per kilogram, but it can potentially accommodate 15 grams per kilogram. This ratio, by the way, of 10 grams per kilogram divided by 15 grams per kilogram is the definition of relative humidity, which is thus around 67% in this case. Now, the other two sets of lines are both called adiabats. They represent how a hypothetical air parcel's temperature will change when it is displaced in the vertical direction, but no heat is allowed to be added or subtracted from the parcel. So in these cases, we are imagining that all temperature changes are coming from adiabatic expansion or compression, the parcel doing work on its environment or the environment doing work on the parcel, and or the release or sequestration of latent heat from water vapor condensation or evaporation. The dry adiabat lines, as the name suggests, represents how temperature would change for a parcel that is subsaturated, or taking the perspective of a parcel lifted from the surface, we would say the rate at which a parcel would cool if it is unsaturated and thus no latent heat is released. The other set of adiabat lines and the last set of lines on the diagram are moist adiabats. The moist adiabats, as the name suggests, represents how temperature would change for a parcel that is saturated with respect to water vapor. Or taking the perspective of a parcel lifted from the surface, we would say the rate at which a lifted parcel would cool if it is saturated and thus latent heat from condensation of water vapor is being released. Notice that the moist adiabatic lapse rate, the rate of temperature change, is almost the same as the dry adiabatic lapse rate at temperatures below negative 40 degrees Celsius. The slopes of the two sets of green lines are nearly parallel. This is because the saturation mixing ratio, and thus water vapor content, is so small at such cold temperatures that there is very little release of latent heat, even in saturated parcels. On the other hand, a saturated parcel at around 30 degrees Celsius can have orders of magnitude more water vapor content, and thus latent heat release can inhibit cooling much more effectively at these temperatures. The result is that moist and dry adiabatic lapse rates are much more different at warmer temperatures. The slopes of the two sets of green lines are far from parallel. Note that even at very warm temperatures, the moist adiabatic lapse rate is still showing cooling with height, even though it tilts towards the right in the skewed temperature coordinate. Okay, those are the 5 sets of lines on the Skew-T Log-P diagram.
That's about as technical as you'll ever need to get in terms of Skew-T. What I'd like to do now is show you a video of how you can apply that.
Okay, so this is the Skew-T graph. On the right hand side we have altitude from 0 to 32,000 feet, and across the bottom we have temperature from minus 30 degrees up to positive 40 degrees. The only lines on this graph that change, the main part of the graph, are the red actual temperature line, the blue dew point temperature line, and the dotted black line, which is the lifting air line. All the other lines behind are just reference lines, and I'll just go through and highlight each of those and explain what they are. So these are isobars, or height, the horizontal lines. For example, if I want 8,000 feet, I just draw a horizontal line across. 14,000 feet across. Isotherms, this is basically the temperature. So if I look at 0 degrees, the line going up on an angle here to the 0 at the top is 0 degrees. The next one over is 10, 20, 30, etc. So the temperature is read on that angle. These lines are the dry adiabats, or the dry adiabatic lapse rate, and they just indicate the cooling of the air, 3 degrees per 1,000 feet. And this is the saturated adiabatic lapse rate, so these lines reference the cooling of the air at 1.5 degrees per 1,000 feet. So I've labelled a few other things on the graph here for you. What I'd like you to take note of is the inversion, which is where the red line turns sharply to the right. This area here, as it increases with temperature and altitude before it starts going back to the left again. And the next thing to look at is the black dotted line. When you see that, I want you to think thermals, convection, lifting air, sometimes called a lift line. And you can see the line starts out running parallel to the dry adiabatic lapse rate, and then it changes direction and it follows the saturated adiabatic lapse rate line. Now where it changes direction is where it turns into cloud, so that's where cloud base is going to be, just over 2,000 feet. And this line here where the where it hits the inversion, about 5,500 feet, will be cloud tops. So that's the first thing I want to look at, cloud base, cloud top. That's reflected on the left as well with the low cloud. And I want to look at the wind, which is in this area here. And off this line here we've got lots of lines and barbs, and that gives us the wind strength and direction. So for example, right up the top here we've got a westerly 30 knots, and right down here about 8,000 feet we've got an easterly 10 knots. And there's some examples there to show you how to read it. We've also got this line here which shows the wind speed. So we've got 0, 20, 40, 60 knots. So we're starting at about 30 knots up here, down to 20, down to 5, and coming down back up to 20 again, just about. So that'll show you the wind speed at altitude. So now we're going to look at a good day. So first thing I want to look at again is cloud base. And if you look at the black dotted line, you'll notice that it follows the dry adiabatic lapse rate, but it doesn't change direction. And that's because it doesn't condense into cloud, so it's going to be a blue day. So cloud base is at 4,500 feet. You can see there's a bit of distance between the blue line and the red line, which also indicates that it's going to be a blue day. You can see on the left, we've got some high cloud up there. And this flight was actually a 78 kilometre out and return flight that a pilot did, and he reported mostly blue. Convergence had light winds and just enough cloud to mark it, so the high cloud mustn't have affected him very much. And we can see the wind here is about 5 knots up to the inversion, and it's southwest, so quite light. On the right hand side here we've got the thermal updraft velocity page, and that is yellow, so it's about 500 to 600 feet per minute with no little black dots or stipple on it, so that looks very good. If we go to the convergence page, the area that the pilot's flying in is this area here, and we can see that the convergence goes through that area, and on the right we can see the pilot's track log took a similar path out and back. Here is a bad day, so we've got on the left we've got high cloud and low cloud. We've got a 2,000 foot cloud base just over. We've got 18 knots of wind, and you can see where the blue line and the red line touch. There's possibly going to be rain as well. Overdevelopment. This is what overdevelopment and thunderstorm potential looks like. If you look on the Skew-T, you can see that with our lift line changes direction there. So cloud base is about 2,500 to 3,000 feet, but there's only a very small inversion there, which is not enough to stop the saturated air from just going all the way up to about 28,000 feet. So this day was forecast for thunderstorms, and I'm not surprised. On the right you can see the Cape page has a lot of dark reds in it, so that's a very high value as well. And the Cape value is also here on the Skew-T. So the really high values like that, overdevelopment, thunderstorm potential. And I'm going to leave you with the Cape page, the convective available potential energy as well. So yeah, cheers, hope that helps.
The thing that a lot of videos on Skew-Ts actually don't explain very well is that the parcel of air that's leaving the ground will follow the dry adiabat, basically this orange line. It will follow this until it saturates. And the way to find out where it's saturated is to go to the dew point on the ground and let it follow up these dotted mixing ratio lines. So this dew point on the ground will follow the dotted mixing ratio lines until it hits the air parcel going up. And that's the point when you stop following the dry adiabatic lapse rate and follow the saturated adiabatic lapse rate, which is the green. So you come up here until these two converge, and then you move up. Based on this windy forecast, so we're talking about light-ish northeasterlies quite early on in the morning. Do you think that that forecast is flyable? So I just like to put another poll out. So based on that windy.com forecast, which of those three options would you take? And there is actually more than one answer. It was slightly misleading when I said that there is more than one answer. If you saw that and it was middle of summer, you could possibly say, yeah, I'm just going to go and do something early morning. If we look at the sounding on this day, you can see that there is an inversion very, very close, less than 1,000 feet. And there is a massive wind gradient. And this is very, very typical in the winter, particularly in the UK. Because of the diurnal cycle, you end up with very cold air in the valleys, an inversion and warm air above. And cold air wants to go down because it's dense. Warm air wants to go up. It's got lower density. And the two do not want to mix. And you can end up with a layer with different wind speeds in terms of direction and also in terms of strength. So there's a massive increase in wind speed here. If you look at windy and put the weather picker up, that will show you 20 miles an hour. Now that is average wind speed at 600 meters, which is a little bit higher than upper takeoff at Pandy. But we've gone basically from 4 to 20, and that's excluding the gust factor. So it is always very, very important to look at the sounding to identify what the change in wind is doing in speed and direction as you go up in altitude. And I remember this day well because my wife and I were mountain biking in the Black Mountains. And although it was relatively light in the valley and to some extent we were sheltered, as we got higher up and then we got up to Crug Moor, it was absolutely howling and our bikes were being blown sideways by the wind. Even though lower down, it was relatively light. So it's always a good idea to look at the wind at altitude. This is a sounding that occurred back in October 23, a place in the Pennines called Parlick. You can see that there's not only a low inversion, but there's also significant change in wind direction. It's southeasterly here, southerly just at this point here, and then above the inversion it's southwesterly. So there's a 45-degree wind shear, and wind shear doesn't have to be 180 degrees out to be very severe. Wind shears of 45 or 60 degrees are significant enough to cause you problems if you get into that shear layer. So always consider the winds at altitude, particularly winter. Significant low-level wind gradients are common in the UK. One thing to be aware of is that within RASP, you can look at boundary layer wind average, which will be coloured on your diagram. But because the boundary layer will be at the inversion height, you could well go to a site above the inversion and start flying. And the boundary layer average wind that RASP is shown in colour on the colour diagram could be significantly lower than the wind you're going to encounter because you're above the boundary layer, you're above the inversion. So you need to look at the RASP sounding. You can look at windy out of Ventuski to look at what the wind is at the altitude that you are going to take off. And on this day, there was actually a very nasty accident. I'd just like to show you this video that gives you some idea of what happens when these shear layers actually cross.
It's crucial the layers don't mix, and in both cases we now have the denser salt water below the fresh water. When the layers have settled, everything's calm, the apparatus is tipped. Now the salt water's flowing that way and the fresh water that way. And there's our effect in tank 1. Here are some more camera angles.
So that gives a really good visual representation of what happens in that shear layer. And some time ago, I was at I went for a flight. That was my 100-hour flight, and I went for a flight at Van Her Ridge, and I looked at the sounding before I went, and sure enough, there was an inversion with a shear layer in there, and boy, did I know when I got into that inversion. It was a bit like doing a mini SIV course. Fortunately, I got above it and had a fantastic atmospheric flight. If we look at this sounding here, the other wind forecast showed it's going to be roughly a southwesterly wind. What's your interpretation of that sounding? Would it be worth going over there for soaring, considering it's a west to southwesterly and the wind speed is something less than 12 knots? So I'd just like to ask you another poll. I didn't go there that day, but people from our club did, and these are the pictures that they sent back from the site. So no, it wasn't really soarable. And then finally, I would just like to ask you one more question. Is this day an XE flyable day? So have a look at that sounding and from what you've learned to date. Is that going to be flyable? So the last poll, 100% of you have said it's flyable. And you can basically see a very high cloud base, almost 6,000 feet, almost effectively a blue sky day, because if you follow this dry bat up, it's only just clipping here. So almost a blue sky day. And there's a small inversion to stop overdevelopment. The winds are westerly and they're relatively light. For cross country, we'd normally like to see winds somewhere between 5 and 10 miles an hour to trigger the thermals off. If you're soaring on a ridge, you want normally at least a minimum of 8 miles an hour. Ideally about 10 to 15 miles an hour. More experienced pilots will be able to take off when it's 20 or maybe above miles an hour, but most of us want to take off when it's about 10 to 15. Some people nowadays are going to Malvern and they're taking off in 20 mile an hour winds, even though the wind speed's going to pick up because they want to fly downwind and do 200 or 300k. But the wind speed here is not changed with altitude, so it looks quite good. And on that day, the star rating all over the country was 5 stars. This is at 11 o'clock. When we look at the star rating of this area at 5 o'clock, it got even better, bearing in mind that the sun is overhead at 12, so you're going to have maximum heat release at about 3 o'clock, 4 o'clock in the afternoon. Buoyancy shear ratio was great, well above 5. And by the time you got over here in the east, it was even better. Thermal updraft velocity was mostly all red, and the thermaling height was equally 5,000–6,000 feet. So it was a very, very good XE day. And on that day, 28 flights of over 200 kilometers. So the 3rd of July was a great flying day in the UK. So that finishes the presentation. So have we got questions? Can you please put those in the chat, either on the weather or anything else?
Okay, so my observation for lower airtime pilots is that there are lots and lots we've seen of different sources of information. And my suggestion for you, until you get used to them, is to pick the ones that you think you get on best with and stick to them, because then maybe one or two. Personally, mine are XE Weather and RASP, because if you follow the same process when you're trying to work out whether it's going to be flyable every time you want to know if it's going to be flyable, you are going to have much better internal cross-referencing in your head between what you saw and what actually happened on the day than if you use multiple different sources all the time. It'll be much more difficult for you to remember which ones appeared to be more correct or work better for you in a particular situation on other days.
Yeah, certainly you can get overwhelmed by the amount of information now.
Yeah.
So thanks for that input, Rick. This was my final slide, which I forgot to show. So my go-to quick look on the weather is to look at Windy and all the forecast models, look at the star rating on XC Para, look at the convergence on XC Para, look at the RASP sounding, the buoyancy shear ratio, and then calibration on the day with the weather station.
Yeah, mine is essentially the same, but my first step is different to yours. My first step is XC rather than Windy. I just don't find Windy is
XC Therm.
XC weather.
Oh, XC weather. Oh, that's interesting.
Yeah.
Okay. And
Yeah.
what parameters do you look at there, Rick?
I'm looking at the two wind speeds, and I'm taking the gust speed as a kind of approximation for what it's likely to be on takeoff. That's personally what I do. I just find Windy overcomplicated, and I can't see it at a glance as easily as I can for a particular location on XC. But then I've been using XC since it came out 25 years ago, so it's a bit habit as well.
Do you know how it compares in terms of absolute numbers with Windy?
I know how it compares in terms of absolute numbers with wind speed experienced on a launch. I find that normally the gust figure on XC is actually a really good proxy for what it's likely to be in the Venturi in a launch zone.
That's interesting.
That's my experience, but other people's mileage varies.
Thank you, Rick. Do we have any more questions?
There was certainly a question of how far in advance are the Skew-Ts accurate? From Annabelle?
Yeah, Skew-Ts, you can look at Skew-Ts for a few days in advance, but they're only based on the predictions from the weather models. It's always a good idea to look at the Skew-T on the morning because the data that's on there has come from the weather balloons. Having said that, some areas and some countries send up weather balloons more often than others. But on the morning you fly, the data that's on the sounding is more likely to have come from the weather balloon as opposed to a prediction.
More of a flying question, I think. It is difficult without experience going XC to visualize how much overdevelopment is too much. Any tips on when to land?
Yeah, I guess this one was just an observation one, really. Just in terms of, I think for lower airtime pilots, you're more likely to sort of be freaked out by, looking at overdevelopment. I know I've done it myself. I've gone to land and actually, I was a bit too much on the conservative side. So it's just kind of, I guess that comes with experience, but
it depends on the country
when
as well.
when to visualize that.
In the UK, you can get massive gust fronts from them, whereas in places like Colombia, you have these storm cells that don't merge and don't take over the whole of the flats. So you can quite often fly even with storm cells visible and not get a lot of wind. But generally speaking, if you see big storm cells up ahead, it's a good idea to fly in the opposite direction and land is the best general advice for that. So Pandy, it's a westerly tomorrow. That's no good. So let's have a look at Hay. Hay Bluff is westerly, so that's not really. Thursday's looking better in terms of direction for Hay Bluff, 4 to 12, but that's not looking at the altitude. The wind is off at Hay. Maybe Fockery might come on in later. But if we look at the sounding for that, custom sounding, and go to Hay.
It's not that far off at Hay.
No,
Anything north of west is doable at Hay.
Yeah. So this is, so there's going to be cloud, a lot of low cloud in the morning. But this is suggesting the cloud base is going to be at roughly at the top at 2000 tomorrow. And if we go on to later on in the day, it has gone up a bit, but there's still quite a lot of cloud there tomorrow. Thursday is quite light winds on Thursday by the look of it there. Tops about 3.5. It's 4, so it's quite light. The weather keeps changing a lot, so your best shot is really to look at Hay forecast for tomorrow. To Wednesday, look at the Hay forecast for Thursday. Let's look at Aberdare to see what the wind is doing on Wednesday at Aberdare. I think is the closest station. Aberdare on Wednesday. Again, a lot of cloud around. Not significantly increasing with altitude. It's about 12 miles an hour, so it looks like the issue is going to be cloud, low cloud. So let's go back to windy at Hay and look at the meteogram. So there you can see all the low cloud that's been predicted on all the Skew-Ts. So a lot of low cloud in the morning and in the afternoon, in fact all day. Thursday's looking better, particularly after midday, and the weekend is not looking good at all. So I think the stopper from flying tomorrow looks like it's predicted to be cloud, low cloud. If you look at XC Para for 1 o'clock on Wednesday, there's not a lot going on cross-country wise on Wednesday. Thursday, there is some thermic activity, interestingly. So Thursday potentially looking like a weak, but possibly potentially a cross-country day, particularly the further east you go to some of the Avon sites, Malvern. The wind is southwesterly. So that's my take on the forecasts. Okay, thank you very much, everyone. And I'll try and do another one in say 2 or 3 weeks' time on instruments. Thank you.
Thank you very much, Chris. Superb.
Thanks, Chris.
Thank you.
Cheers, Chris. Nice one.
Thank you.